Hello and welcome back to another episode of Brandon Does Cyber. It's been a while. Let me preface this with just some updates of what's been going on, why we've been uploading as much, and kind of the overall status of the channel. So, college was a little bit more than I was expecting. So coming back into it, some of the classes that I was going to be learning and working on were a little bit more of a time dedicated to make sure that I was doing the things I need to be doing. So, for context, I'm currently doing a bachelor's degree in cloud computing. So I know I have a cyber background, but before that, I had a networking one where I was doing a lot of network operations, working with switches and routers and things like that. So I feel like using cloud computing was a good blend of mixing that for cybersecurity, right? Because a lot of things are going into the cloud, and then as well as bridging that gap with my networking experience as well. So kind of incorporating both of that together so that way I can actually have both and use it relatively for cybersecurity or for networking stuff as well. I do have an associate's already in cybersecurity, so I also wanted something kind of different, but still having cybersecurity as my main focus and my main priority of what I want to do and learn as a person. So, yeah, the past two classes have been a little rough. It's just making sure I had that time dedicated to it, making sure that I'm doing what I need to be doing for it. So, just kind of focusing in on that. And then my work situation. So, I have been doing another training range. I don't remember if I mentioned that at all in my past videos or not. So, originally I had a training range where we would use to train some of our operators that are working on our systems. So it was targeting a lot of our network capabilities. And now I'm creating one for our host capabilities. So being able to actually go in there and identify IOCs and TDPs and using MyRTag and all kinds of that fun stuff. So really cool. I've been actively making, I guess, quote unquote, malware. Um, Not really malware. It's more or less just a PowerShell script that will do something, right? But still, the idea and the intent is still there. Hey, this is something suspicious. Let's figure out what's going on. So, really trying to help gear our operators toward that mentality of kind of how we're studying here for SOC level 1 of how do we identify that host level? How can we figure out this is a legit, alert or this is a legit um, malware? How do we respond to that? How can we actually go in and find it and clear from the system, figure out ways that they got in and prevent that from happening in the future? So for that aspect for work, it's been really fun. Been working on that. I think I'm almost done with it, so I'm super excited to release it for our people and let them kind of play around, see what they think. And then with life in general, right? Just like I said, just been really busy working on those two things. So I haven't really had a whole lot of time to do a lot of TryHackMe. I know I mentioned that I wanted to do an episode a week, and that was my plan and my goal. But unfortunately, again, just things were kind of piling up, and I was like, well, I need to focus on these things a little bit more. So I do apologize again for the delay. For those that know me in real life, or maybe if you follow me on LinkedIn, you may see some of that where I'm just like, oh, I'm scrambling, working on different things. So hopefully you understand. I do, like I said, I do apologize for not being able to do what I've been wanting to do, where I've been really focusing in on this. So, and then as well for professional, I guess, advancements as well. Um, this month, I've actually started my course for SANS 577. So, for those that may not know what SANS 577 is, it is Linux incident response and threat hunting. So, really excited for this. Super, super excited for this. um, there's a lot of cool things. So, using tools, techniques to hunt a variety of adversaries, hunt third party response on like systems, look at different C2 channels, right? Breaches, occurred, all kinds of different stuff. So, I already have SANS 504, which is the GCIH, which is incident handling. So, being able to do Linux incident response and threat hunting is really cool. Super stoked for it. So, again, for those that know me in real life and on see my stuff on LinkedIn, you'll go, you'll see. Hopefully, I'm praying. But when I do take it, that I can pass that, and you'll see that certification on there. So, but enough talk. I know you guys are here for the lessons and learning, so we're gonna jump right on back into it. We had originally finished the T-Shark session. I think I did it, but I don't know if it actually uploaded on YouTube, so I had to verify that. But if it did, cool. If not, well, you'll see that with this as well. But we're going to be moving into the endpoint security monitoring, and so intro to endpoint security. So let's open that up. Cool. So endpoint. So here we go. We have the room introduction. So in this room, we're going to be introducing the fundamentals of endpoint security monitoring, some essential tools, high-level methodologies, and giving an overview of determining a malicious activity from an endpoint and mapping it to the related events. We're going to start with and tackle the following topics. So security fundamentals, logging and monitoring, and log analysis. And then at the end of this room, we're going to have that threat simulation where you can investigate and remediate the infected machines. And this activity may require you to understand the fundamentals of endpoint security monitoring to complete it. So I read and understood the introduction task. Let's see, this is going to take a delay. Let's refresh real quick. Okay, yep, there you go. All right, moving on. All right. Core window processes. Before we deal with learning how to deep dive into endpoint logs, we need to learn the fundamentals of how the Windows operating system works. Without prior knowledge, differentiating an outlier from a haystack events could be problematic. To learn more about the processes, a built-in Windows tool named Task Manager may aid us in understanding the underlying processes inside a Windows machine. Task Manager is a built-in GUI-based Windows utility. This will allow users to see what is running on the Windows system. It's also going to provide information on resource usage, such as how much each process utilizes CPU and memory when a program is not responding, and the Task Manager is used to terminate the process. Task Manager provides some of the core Windows processes running the background. Below is a summary of running processes that are considered to be normal behavior. Note the arrow symbol represents a parent-child relationship. So the system parent to the smss.exe child process. Here we see system, and a system which will spawn the smss.exe child, csrss.exe, when init exe to services.exe, and then when exe serves exe and service host, lsas, when logon and explorer. In addition to, actually, before I move on, let me actually copy these. It's always important, right? We always try to take notes as much as possible. Try to start back with a good habit. In addition, the process with no depiction of a parent-child relationship should not have a parent process under normal circumstances. Except for the system process, which should only have system auto process 0 as its parent process. And then you can also refer to the core process room to learn more about this topic. And so here we can go through all of this right here. So I think it's the very next one. Okay, cool. So we'll be going with that shortly after this one. And then with the prior knowledge of the core Windows processes, we can now proceed to discuss available tool sets for analyzing running artifacts in the back end of Windows machine. Most of this is going to be using sysinternals here. So if you haven't used sysinternals, it is a suite of tools made for Windows. I think it was used to be. I'm not 100% sure. I believe it used to be packaged with the Windows installation, and then over time they kind of just made a separate package that you could just download if you wanted to. But it has all kinds of different tools, different tool sets here that you can use. I'm actually using sysinternals. One of their tools is psexec, or basically it's a remote tool that you can use to run commands or run files and scripting. So I use this heavily in the host space range, so that way we can run remote commands and do remote command execution. So sometimes with some of the sysinternals tools, they can be super powerful, like psexec, because psexec, it wants to run at the system level, which again, authority wise, right, you have your NT authority system, which then goes into like your administrator and then like your user and then maybe like a guest account, right? So it runs at the system level. So you have to be very careful with using these tools and who has access to being able to use them. So be very mindful with that. If you do have system internals, what users are actually allowed to run them. Obviously, you don't think a regular user should be running PSExec if that's not their daily functions or anything of that nature. So just be mindful. But they do have tons of tools that are extremely helpful and very, very, very useful. Using it just for internally, whether it be for enterprise or if it's just a personal machine. So here we can see something like TCP view. I think probably the most common ones that you'll see is TCP view. You'll see Process Explorer. There's also auto runs. We'll pull that up real quick for you. I think we've used system terminals in the past on this channel. I'm not sure, but this is a good little example of what that looks like. So here you can see all the different scheduled tasks or services that are on the system, where they're starting at. So here's all the auto runs on the system, right? You can see where they're located at for the registry, right? Or you can see the file path too. So here we can see, there's a for the current user, their auto runs with all these settings. And then here we have some that run once, so we'll just run execute, and then that'll be it. But there's all kinds of different stuff. We don't get into that right now, but just something to be heads up and to be aware of. But TCP view, this is mainly for your TCP UDP connections. Basically, you're just netstat. So if you do netstat tac ano, it's going to give you all the IPs and IPv6 addresses, but this one kind of links it to an actual process of what spawned it. So here we can see all these UDP protocols, the parent, excuse me, not parent, but the process ID of them. So you can see system F4, service host, Chrome. So we can see here with Chrome on this PID here of a local address and a local port. And maybe say you're connecting to somebody's server. So like TryHackMe. If I have Chrome, or in my case, I'm using Brave, right? You should see Brave.exe, the PID of it, probably TCP because of an HTTP connection, having that handshake. And then my local port that it's running off of to the remote address of whatever TryHackMe's IP is and their port. And then we have Process Explorer. So this is going to show you the different services that are running, all the active processes. So this includes the name of the owning accounts. So the information is displayed here. So you can see the service name is web client, the display name is web client, and then you can see the path of where it's located at. So maybe if you see some weird service name, you're like, what is that? Then you can see, okay, maybe we figure out where it's located at. Or maybe you're doing kind of like a baseline, or maybe you're going through and saying, hey, what's normal on the system? And we see the display name of just being blank. We're like, what's going on there? So maybe we want to check that service out. And so here you can see the DLL is memory map files that the process is loaded. So DLLs, this is the official definition. So DLL mode, hold on, let me back up. Let me make sure I get the rest of it because this is the definition of it. So if it is in handle mode, you'll see the handles that the process selected in the top window has opened. If Process Explorer is in DLL mode, you'll see the DLL's memory map files that the process has loaded. Okay, let me copy that. So I'm already really familiar with the NetTCP, or not NetTCP, excuse me, that's PowerShell I'm thinking of. TCP view. I'm already really familiar with this, so I don't really feel like I need to take too much notes. I guess I could. It's not going to hurt. But I'm very, very familiar and very confident with TCP view. And a lot of the system terminals tools are very easy to use and kind of easy to see where they're working at. See, there's the system terminal rooms. Let's see if we did it. I feel like we did. No? Okay. I thought we did it at one point. Well, it's in this section, so we'll get to it eventually. So the normal parent process of services.exe. So we go back up here, right? So services.exe we can see is when init. So the initializing of Windows. So when init.exe. What is the name of the network utility tool? This is TCP view. So some endpoint logging and monitoring. If you're in Windows, your best friend is going to be your Windows event logs. So the good thing about this is you can port them like in, or you can export them out. So maybe you have like a seam or something you want to export those logs to and check out. But for your Windows, for just maybe your regular user or your at-home computer, you'll have something like Event Viewer where you can go in there GUI wise, or WebUtil for command line, or get WinEvent for PowerShell. Sysmon. This is a tool that's also going to be used to monitor and log events on Windows. I think it's not only for Windows. I think other services use Sysmon as well. Um, but it's commonly used by enterprise as part of their monitoring and logging solutions. So I would assume, yep, it's not just Windows. It's part of the Windows System Controls package, Sysmon is similar to Windows Event Logs with a little bit more detail and more control. So it's going to gather those high quality logs and event tracing, assist in anomalies in your environment. So it's going to be commonly used with the security information event management, SIEM. So yep, or other log parsing solutions that can aggregate, filter, and visualize those events. So things like Kibana or maybe Splunk, where you want to get those logs specifically. And then lastly, Sysmon includes 27 types of event IDs, all of which could be used within the required config file to specify how the event should be handled and analyzed. And here is an excellent example, auditing different event IDs created by Swift on Security. So let's check out what he's got going on over here. So here you see the export. They're installing it with administrator rights and just moving on. So if you're interested in that, you can check his page out, his or hers, or their page. And then there's also another Sysmon room, which I'm assuming, yeah, we're going to be doing. A lot of these rooms that it's mentioning are all inside this. So, and then OS Query. I'm not super familiar with OS Query, but it is an open source tool created by Facebook. So let me. Well, okay, it is an OS Query room. We'll just copy this when we get to that room. I don't want to copy it twice and be confused. So it's an open source tool created by Facebook. So OS Query security analysts, incident responders, and threat hunters can query an endpoint or multiple ones using SQL syntax. OS Query can be installed on various platforms. So you got Windows, Linux, Mac, and FreeBSD. So a wide range there, right? And then you can interact with it by opening up some type of shell or console, or here they're even specifying the command prompt or PowerShell, and then just running the OS Query I. And then you're into that interactive shell. So here you can see that they were on Windows, they did the query, and now they're into that interactive shell. And so here, yours looks very similar to PowerShell. So if you're familiar with PowerShell, it looks like kind of like select tech object, the PID, the name, the path, right? And the process is that where object kind of thing. But so you have selecting the PID, so the process ID, the name of it, the file path from the processes, where the name will be equal to LSAS. So here they got the LSAS PID and the path. So maybe they want to see something weird's going on. Maybe they have like 2 LSAS, which is not normal. So now you want to go investigate that. It allows you to query events inside the machine, but with Collide Fleet, you can query multiple endpoints. So here, this is like an actual endpoint tool that you can use from the Fleet UI instead of using it locally to query an endpoint. So here you can see there's a show of a query result listing the machines with the LSAS process running. So here they have only one host, but they ran LSAS, and they can see the Windows name, the command line of how that process would be executed, right? The current working directory of that process, and then the bytes read or written. So that's actually a pretty cool tool. I actually might be implementing that because I like having that UI. So might be taking that. Waza is an open source, freely available, and extensive EDR solution. This can be deployed in all scales of environments. So it operates on a management agent model. So basically, you would have this. Oh, excuse me. You would have this GUI here, right? Whether it's installed on some server or something, and then these agents would be installed on the individual host machines, and then you can interact with those specific agents. And in some cases, you may be able to actually console into them, run commands on the host, whatever it may be. I'm not too familiar with Waza as in actively using it and in like a real world sense. So I'm not too familiar with it, but we will definitely get to it because it's here in this section as well. So it is an EDR. So an EDR is that endpoint detection response tool, and applications that will monitor devices for an activity that could indicate a threat or security breach. So you're going to have things of eyeing device for common vulnerabilities, being able to proactively monitor a device for suspicious activity. There's even things such as like maybe we're looking for unauthorized logins, brute force, or privilege escalations. You can view complex data and events into neat and trendy graphs, and you can record a device's normal operating behavior to help with detecting those anomalies. So here, you'll see here in the seam section, this looks extremely similar to things like Kibana, right? If you worked with things like Security Onion, or the elk stack and just in general, it looks extremely similar. You're having the query, you can add filters. Looks like you have like a little dashboard so you can see the graphs and times. You can even see some of the alerts that are going on here, the time frame. It's extremely familiar. I would dare say it's probably built on top of the elk stack of like very similar of it's just the way it's processing this dashboard is just different. So but it's a really cool tool. Definitely cool. So where do the Windows event logs typically reside? So Windows, I'm gonna say System 32. I don't remember off the top of my head. Uh, where is the sort at? Win event. Oh, okay. I was like, I don't think logs is that one, but I knew it had something to do with logs. Used to enter OS query, so it's like OS query I or nope. I'm sorry. Nope. There you go. EDR, so endpoint detection and response. Oh, well, cool. Said it all in lowercase, but I had a capital letter. Oh, I didn't even submit it. Oops, my bad. All right. All right, in our site. So endpoint log analysis. Ah, man, I love me some Windows XP. I remember all the time, good old Windows XP having this background. So for, I guess, those that may not be familiar, Windows XP, if you know me in real life, I've mentioned this before, is probably my favorite operating system. And it's not because of any of the capabilities, but all because of this one funny little thing is the pinball game on Windows XP. Little Space Cadet. Loved it. Had a great time playing with it as a kid. A lot of good memories with my parents. We had a super old computer, but playing around with this and just shaking the machine and then it breaks. But good times. Anyways, event correlation. This identifies significant relationships between multiple log sources, such as your application logs, endpoint logs, and network logs. This is going to deal with your significant artifacts coexisting from different log sources and connecting each related artifact. So here's an example. A network connection log may exist in various log sources such as sysmon or a network connection and firewall. The firewall log may provide the source destination IP and the port and protocol, and in contrast, the sysmon may give info about the process that actually started that network connection. So kind of like differing how does the machine produce that type of log, right? So if I'm using things like sysmon, right, I'm going to get more about the system itself. I'm going to get information about what the process started, how is it executed, where did it execute from, who's the parent of that process that was executed, right? A lot of information about the host. Whereas if I'm wanting specifically network traffic and network connection only, I may look at the firewall log because now I'm getting information about the IPs, the ports, the protocols. So it depends on where you're trying to get out of your investigation, right? Are you trying to figure out what process started it? Are you trying to figure out what is it connecting or reaching out to? Things of that nature. And so here we can connect the dots of each artifact from the two data sources. So here you got the source destination of the IP and the port, different actions that are taken, the protocols, their name, the user account that actually executed the process, and then the machine that executed on, right? All of it is relevant and useful information. And baselining. So this is a topic that I think I mentioned quite a bit, but maybe I've never actually gone into. I don't know if I have, but it's also been a while too. So, baselining, this is a process of kind of setting the standard of what we know to be normal. Okay, a lot of the ways we would baseline is maybe something as simple as just doing like a directory walk from the root of the file system all the way down, right? From the C drive all the way to the very last file in the system, just so we can get an idea of what's on the system, what's not. And then things of like processes that we are actively wanting to be running on the system. So maybe it's common for you to have Discord up on your system. Well, if I am coming in to do some type of pen test, or if I'm doing some type of exercise to see if there's anything kind of weird on your system, and you give me a baseline document saying, hey, this is what's normal, what's not normal, and Discord's not on there, well, then I'm going to assume that you're compromised because now there's something on there that's not shouldn't be there, or there's somebody who's installing stuff that shouldn't be installing stuff. Maybe it's a privilege issue, right? So baselining is useful for just allowing you to be able to understand what is normal and what's not normal. And here they go into a little bit more detail. So the working hours of 9 a.m. 6 p.m. So then you see someone connecting from, oh, they also mentioned that they're from London, but then you see someone connecting from Singapore at 3 a.m. That's weird. You can see a single workstation assigned each employee, but then you see one employee is authenticating to multiple workstations. It's weird, right? So we could just go down the list. You can see, here's some O365. You can see some different Microsoft applications, just different things of that nature. So, and then you can, once you've tackled the foundations of endpoint security monitoring from previous tasks, they're going to wear that blue team hat and apply the concepts by investigating suspicious activity detected on that workstation owned by one or more of your colleagues, right? Oh, excuse me. Owned by one of your colleagues. Well, the workstation is owned by one of your colleagues, but the activity could be on more than one person's workstation. You get the gist. So let's go ahead and get into this little site. So this machine has been compromised. Identify and remediate the threat. Sounds good. So here we have the different processes. It says identify the abnormal running process. So here we have a baseline document. So let's pull this up. Can I move that? Nope. Okay. So here we can see some of the normal processes. We can see CRSS. That's there. Cool. SMSS. Cool. WinInit. Cool. WinLogon. Explorer. Services. But there's this beacon, I'm guessing is what it's saying. Beacon.exe. Yep. That's weird. So now we found this beacon. So now we should probably try to see what is its parent ID, or its process ID is, where it says location, it was connected to anything, right? So here we see we've identified the malicious process, determined the malicious network traffic, and you may refer to your notes. So here we see service host, and beacon. So there's beacon. We can also see 4444, which is interpreter's default port. So this also suspicious. This only has the malicious IP, but also include port, and then the process that's causing it, which is beacon, and maybe if there's like some other type of connection, maybe it's going through Google Chrome or something, maybe include that as well. Find all machines affected using Discover IP. So we'll do 59, 23, 48, 195. So you see there's 4 workstations. That's bad. Let's remediate that. And we got it. Cool. We've got it. Let's get the flag.txt. And there it is. Sweet. And in conclusion, so we've completed the investigation task. We've simulated in the simulated activity, we learned how to how the baseline document aids me, how to event correlate, taking note of the significant artifacts and other potentially affected assets. And then we also learned about some of the fundamentals, some log and monitoring, and some log analysis. And then we're going to deep dive into the rest of this, these different tools and how we can use it for endpoint security. So, cool beans. That's actually become my little saying now. It's cool beans. I don't know why. But yeah, cool. So we have intro to endpoint security done. Now we're going to be moving on to core Windows processes. So it looks like there's a machine. Let's start that up. So yay, we did it. Cool. So I'm going to let this load up and then I'll be right back. Alright, looks like it's up. So introduction. In this room, we're going to be exploring the core Windows processes for a Windows system. It's going to help you to know and understand what normal behavior within a Windows operating system is. And this foundational knowledge will help You identify malicious processes running on an endpoint. The Windows operating system is the most used in the world, whether people like it or not, and the majority of its users don't fully understand its inner workings. Users are simply content and that it works. So, like anything complex, such as a car, it starts. You can drive from point A to B, and that's really about it, right? But regarding computers, if they can surf the web, read, answer emails, shop, listen to music, watch a movie, all is well. It took a long time for users to start grasping that need for antivirus programs fully. I mean, you think back in the day, which, you know, I kind of got it, I guess, on the late end of it. I'm not super relevant to whenever computers start, coming out and things, but people were getting hacked pretty often. Things were out there. I remember people talking about like all the pirated songs or pirated movies, and all of a sudden now your computer's got a virus on it. So now people just kind of want a computer that just dysfunctions, but we have things like antivirus, things like Windows Defender, and antivirus was enough over 5 7 years ago. But time changes everything. Malware and attacks have evolved, and antivirus is no longer enough. Antiviruses struggle to keep up solely based on how it is designed to catch evil. You think about it, there's different types of malware out there, right? It's not just something where I see, something bad like mimikatz.exe. Oh, I know that's bad. Cool, blocking it. Now we have things where, they're encrypted, they're encoded. We have things that like can be encoded to a point where you don't even know what it even says anymore because there's so much encoding going on. It's coded double, triple, quadruple times with different things, and so it's hard to figure out, what is this program actually doing. So it can be very tough to figure out what's these antivirus solutions supposed to be doing, or how is it supposed to be protecting us if it can't even figure out and I can't even figure out what's going on, right? So today, antivirus is just one solution with a layered defense approach, and there's new security tools out there such as your EDRs, and this has just been created because antivirus cannot catch every malicious binary process that's running. So, even with these new tools, it is still not 100% effective. Attackers can still bypass the defenses running on the endpoint. So, this is where we come in. Whether you're a security analyst, SOC analyst, detection engineer, or threat hunter, if one of the tools alert us on a suspicious binary process, we must investigate and decide on a course of action. So, knowing that expected behavior system we had to defend, a Windows system, in this case, we can infer if the binary process is benign or evil. So, here, we just have the split screen view up. We don't have to worry about RDP. Yes, we'll call it the clipboard. And then this is just saying let me in. Cool. Task Manager. So, we can do all kinds of ways. There's right clicking the Windows button and opening it up. I think it's like what? Windows Shift T? Oh, what is it? There's a keybind. Task keybind. I don't remember what's on it. I think it's Windows Shift key. Oh, Control Shift Escape. That's right. Control Shift Escape. What am I thinking of? Windows Shift T. Oh, it's also opening up on the other side. What is Windows Shift T? Oh, I think I know what this is. Yeah, it's for your web browser. I was thinking about that. I was like, wait a minute. So, cool. If you don't have any open processes running right on your screen, so you don't have nothing down here actively running, then you can click on more details. And you can start seeing, whoa, there's some background processes, some things happening here. We can see something like Amazon SSM agent. Like, what's going on there, right? So then there's different tabs. So you have your processes, you have your performance. So maybe you want to see, is my CPU at the max? Is my memory at the max? How is my Ethernet doing, right? My internet connection. You see different users are logged in. So maybe you have a one main computer that a lot of people will log in at. You can see different users being logged in at the same time. You can see some details here. So this goes further into those PIDs, the status of it, who's running it, right? So maybe we see LSAS here is running as system. Maybe we don't want that, which in this case we do, but maybe we don't want that. So maybe we need to figure out that's something we need to change. And then overall the services on the system that maybe stopped, started running, etc. And then here it just kind of goes through everything we just kind of talked about. So as a section above here, they talked about processes. There are processes categorized as follows: apps, background processes. Another category that's not visible in the above is window processes. So we can, there we go. So we have process name. So there's all kinds of stuff. There's also name, status, CPU, memory, and the only one's visible. So maybe we want to do PID2 with it. Maybe we want to do publisher, command line, however much we want to add on, right? So you see all kinds of different things here. Okay, so here they're going over each column. So type was the type of the process, right? Apps, background process, Windows process. Then you have the publisher, who made it, if it's signed. The PID, so the process ID of it, the process name, the command line, very simple. The amount of CPU it's using here, as you can see, you can filter it for who's using a lot of CPU or who's using a lot of memory. And then details, again, this is another view for you to see all those services that are running, or not services, excuse me, all the processes that are running on the system. So here they're saying some good comments to add if you want to. If you want, you can say I want to do session ID or job ID, object, all kinds of different information. GPU, you can just keep on adding on and on to whatever you want. But they're saying here a good one are the image path name and the command line. So if you want that, so trying to see those there, but so. These two columns can quickly alert an analyst of any errors with a given process. And the below image, PID384, is paired with the process name servicehost.exe, a Windows process. But if the image path name or command line is not where it's supposed to be, then we can perform a deeper analysis. So here, we're seeing that this process is ran from here, and the command line execution is this right here. Oh, that service. Of course, you can add as many columns as you wish, but and the columns will be pertinent to your current task as recommended, right? You don't want to be flooding your view. And then you have task managers built in with a Windows utility, but lack certain important information when analyzing those processes, so such as your parent process information. So it's another key column when identifying outliers. So back to the service host. If the parent process for PID384 is not services.exe, then this would warrant further analysis. So here you can see all the different processes again, and then based on the above image, the PID for services.exe is 632. But wait, one of the service host processes has a PID of 384. How does service host start before services.exe? Well, it didn't. Task Manager doesn't show a parent-child process view. That is where other utilities such as Process Hacker and Process Explorer come to the rescue. So again, things like with your Sysinternal suite, you can use tools that will allow you to see that tree of who came first and who's has a child. So here you can see system, and then you can see the different processes that came from it. So here, from moving forward, we're going to be using Process Hacker and Process Explorer instead of Task Manager to obtain information about each Windows process. So let's do Process Hacker. And I guess we'll open up Process Explorer as well. I don't think it matters too much. We'll just do both. Okay, and so here we see the two different processes that are running, or not process, the two different views that we can see for processes, and we can see who started what. You can see system started, and then all these other things that came. So, or here as well, you can see all the different parent IDs and process IDs and stuff. Aside from Task Manager, it'd be best if you also familiarize with the command line. So here you can also do things like task lists or git process or PS with PowerShell and WEMIC. So WEMIC is also another tool that I don't think a lot of people know about. It's kind of fallen off just because of command prompt PowerShell kind of taking control. But WEMIC is still another powerful tool that may be useful in some cases, just to be mindful of. So the first window process on the list is system, as it should be. This is a PID that for any given process is assigned at random, but not in the case for a system. PID for system is always 4. So what does this process do? The definition of this is a home for a special kind of thread that runs only in kernel mode, a kernel mode system thread, and a lot of just stuff. It's a lot of words. See if there's anything actually pulling out. System threads don't have a user process address space and hence must allocate any dynamic storage from operating system memory heaps such as a page or a non-paged pool. So what is user mode kernel mode? Visit the following link. So here, this is that Microsoft's web page where you can see what's the difference and how they differ. You can even see this layer here. So the user is your applications on the screen where you're clicking, working with, and then they interact with the Windows API. They'll then work and interact with the kernel to run those interactions. And then you also have user mode drivers that will interact with the API as well, so that way it can handle those conversations that maybe it doesn't understand. And then these will also handle those drivers with the kernel down to the hardware. So things like your hardware drivers, you all may often hear like, oh, I need to update my GPU drivers or stuff like that, right? So you're updating those drivers so that way the hardware can speak the same language, and that way the applications that you're running can actually understand and talk back and forth. So there's also some other drivers with the kernel and then the file system. So there's just a lot of things that are going on in the background that you may not actively see, but is actually being handled and transacted with the kernel down to the user. So, what is normal behavior for the process? You can see with Process Explorer and view the properties of the system. So here you can see the parent should be none, right? You don't want a parent for the system. That's not how that works. And then the user should be authority system, right? Because the system should be in control. That's anti-authority system is kind of like the kernel. It's the highest level privilege that a person or user, it's not really a user, but the account, I guess you could say, could have on the system. So here, this is what it should be, and then this is how the information is different. So you can see the system properties, you can see the file, there's like a file path, and then we can see there's command line, nothing there. You can see the parent process is a system idle process, so that's a little weird. So you can also say that this is a legit process, right? Because this is the kernel.exe that's actually running. But technically correct may notice the product confirms is legit verified Microsoft Windows. So let's pull that up. Where is this system? For properties. Yeah, so here we go. So you can see it says it's verified, so that's how you can see what it's talking about. So it says it's a kernel authority. You can see it running. So even though the system idle process is up here, right? It's a PID of 0, and this system, even though this is two different looking things, it's still the same. So what PID should system always be? It should be 4. Also, it mentioned that was unusual behavior. Parent process aside from the system idle process of 0. Multiple instances of system should only be 1. A different PID. PID should always be 4. And then not running a session 0. So another thing that people don't really mention a whole lot too is sessions. So your session numbers matter. It's a way for things to be done in separate ways, maybe to not allow users to see, but to be handled more for like the system, the kernel levels. So I'm not going to go super depth because I'm not the best expert on it, but from my understanding with it, there are different levels of sessions. So maybe you want to, when you do like recovery mode or safe mode, right, you may drop it down to sessions. That way you get more of a bare bone interaction. You don't have things like the network you're talking to, and you're not have Google access, right? Maybe it's just only command line, or maybe you don't even have a command line. Maybe you restrict it down to where there's only one user able to log in and not multiple. So things of that nature. Then the next process is SMSS, or Session Manager Subsystem. It's also known as the Windows Session Manager. So it's responsible for creating the new sessions. Is the first user mode process started by the kernel. This process starts the kernel user modes of the Windows subsystems, and you can read more about it here. This is Wikipedia, and it includes the Win32k.sys, the kernel mode, and WinServe.dll user mode, and CSRSS.exe in the user mode. So here we can see a little bit more of a view. So here you have the Win32, POSIX, and OS2 applications, so your environment subsystems that will integrate to your other integral subsystems for your user. And then this is going to go down to your actual executive services. So this is how your system is operating. How is it handling your memory and your processes, your power, your windows, and everything like that. So that's how they interact with each other. And then again, your kernel mode and your hardware that fall underneath. So SMSS starts CSRSS and WinExe in session 0. This is an isolated Windows session for operating system. And then and when logon as well for session 1, which is that user session. First child instance creates child instances in new sessions done by SMSS, copying itself to the next session and self-terminating. You can read more about the process here. It's also on Wikipedia as well. Check it out. And it's just more about explanation of how all that works. So here we can see session 0. So, okay, so here they are. So here we can see there's two different ones. They're not this matching, looks like. But let's pull up the properties of this guy. They put me to token. So here you can see it started session 0. And we can also see for the general side, right, when did it start, who's the parent process, non-existent, which makes sense, right, because it copied it over and then self-terminated. So that makes sense. And then we can also see that it started the WinInit process as well. You can see right here. And go token as well. See, this is session 1. So there's two different ones here. So this is WinInit, and then this is the CRSS and WinLogon. So that's how that interacts. Any other subsystem listed in the required value of the registry path here is also launched. So anything that's required by Windows to be launched. And SMSS is also responsible for creating those environment variables. So virtual memory paging files and starts WinLogon, the Windows Logon Manager. And then what is normal. So you can see the file name is a verified. This is the location. You can see the process command line, the current directory, when it is start, and then the parent ID. And so what is unusual, we can see here that there's a different parent process other than System 4. So we go over here to, let me close these out real quick. So, oh, I guess it doesn't show it here. Yeah, I don't see it. Okay, never mind. So here they're saying that there's a different parent process other than System 4, which here it is. So, that's why I'm kind of confused. The image path is different than System, or C, Windows System 32. That's where it is. More than one running process. So, again, I don't see any. Oh, here's one. Let me go over here. I mean, that's, yeah, it's all the same. Yeah. So, more than one running process of it. The running user is not the system user. And then unexpected registry entries for the subsystem. So, these are some ways you can check. So, aside from CRSS, I think it's WinInit. Or, no, not WinInit, excuse me. WinLogon.exe. So the CSRSS.exe, the client server runtime process, is that user mode side of the Windows subsystem. It's always running. It's critical to system operation. If the process is terminated by chance, it will result in system failure. It's also responsible for the Win32 console window and process thread creation and deletion. For each instance, CSRS, RV, DLL, base serve DLL, WinServe DLL are loaded along with others. It's also responsible for making those Windows API available for other processes, mapping, drive letters, handling Windows shutdown, and you can of course read more on the Wikipedia page for it. Recall that it and WinLogon are called from SMSS as startup for session 1. So what is normal? So here we have this one, we have this one. So let's compare. So we see the image file name, right? So they're both verified. We see the two different PIDs. See that both of them don't have existent parents. See both of them are very similar. Yeah, it looks like both of them are very similar for the process current directory and where it started at. But this one is in session 1 and this one is in session 0. Notice what is shown for the parent process for both of these two processes. And remember, both of these respond by SMSS.exe, which terminates itself, right? So that's where it has one copy and then copies it into session 1 and then terminates itself. So within seconds of boot time of the first two instances, session 0 and session 1, start time for additional instances occurs and new sessions are created. So what's unusual? An actual parent process, because this process self-terminates. Image file path other than system2. Subtle misspellings of hybrid processes, and the user is not a system user. Which have PID 384 and 488. What is a process that had 384 and 488? Oh, for the parent. So that's the SMSS.exe. Or it should be, right? That should be what it have. And then when in it, this is the initialization process. It's responsible for launching services.exe, where the Service Control Manager, LSAS, the local service authority, and LSASIO. I don't think that's how you pronounce it, but all within session 0 is also another critical Windows process that runs in the background, along with some child processes. So LSASIO, I don't know how you pronounce it. LSAISO.exe is a process associated with credential guard and key guard. You will only see this process if that is enabled. So, what is normal? You can see that the file path verified. Here you can see the image location, the command line started, and no parent process. If what is unusual about it, if it has an actual parent process, calls this process and self-terminates. Image file path other than system32, so misspellings, multiple running instances, and if it's not running a system. So, I think that's how you pronounce or spell it. Yeah, cool. Because this is what actually runs with credential guard, but because LSAS is more of your authority, so if it's not there, then well, it's not a good thing. Next process is the Service Control Manager or services.exe. So you're mainly going to be seeing that with sc.exe. It's like command line for communicating with that to create services. And you can also see it stored in the registry here, so all the different services. This also loads device drivers marked as auto start into memory. And then when a user logs into machine successfully, is responsible for sending the value of the last known good control set, or the last known good configuration here to that of the current control set. This process is apparent to several other key processes, so service host, spools, SV, MSM, ping, DLO host, name a few, and you can read more about it here in the Wikipedia page. And you can see it spawns the services.exe and all these other things. So, what is normal? And you can see here the image file name, command line, started, and the parent process. Because again, when it spawns it for the Windows initialization, and then it stays up for the system to run. And then making sure that it runs at session 0 because it is part of that kernel level handling the system applications. So, and then as well, not system applications, the services that are running on the system for that are being created or being ran or interrupted, anything that's going on with the services themselves. So if it has a parent process other than WinInit, image file path other than Windows 32, System 32, subtle misspellings, multiple running instances, not running system. How many instances of services should be running? Should be only one. And then here we can see service host. So service host, this is responsible for hosting and managing Windows services. Services running this process implemented as DLLs. The DLL to implement is stored in the registry for the service under the parameters subkey in service DLL. The full path is HKLM, system, current control set, services, service name, parameters. And so here you can see the example below is the service DLL value for the DCOM launch service. And so you can see the parameters set and that service DLL. So to view the information, right click service host. So where's it? There we go. And then services, it says DCOM launch. Go to service. You can see down here. And in their case, it will be 748. And then you can right click the service here, go to properties, and then look at service DLL. So here you can see rpcss.dll. From the screenshot above, the binary path is listed. Also notice how it is structured. How it is structured. Sorry, what am I saying? How it is structured. There's a key identifier in the binary path, and that identifier is TAC-K. You can see right here, the TAC-K. This is how a legitimate service host process is called. TAC-K parameter is for grouping similar services to share the same process. It was based on the OS design implementation to reduce resource consumption. So starting from Windows 10 version 17.03, services grouped into to host processes changed. On machines running more than 3.5 gigs of memory, each service will run its own process. And you can read more about this process here. Back to the key identifier from the binary path in this above screen. The TAC-K value is DCOM launch. Other services are running with the same binary path in the virtual machine attached to this room. And so you can see here all the different ones. All of them have the TAC-K, DCOM launch, TAC-P. So let me see if I can add that column in for command line. I'll do binary path too. We'll do that for now. Let's see. There we go. So I can see is TAC-K, and then the DCOM launch is where they're all supposed to be. So there's one right there, there's one there. So each will have a different value for service DLL. So let's take LSM as example. Expected value for service DLL. So here they're in LSM parameters, service DLL. They go to the properties, and you see lsm.dll there. So since service host.exe will always have multiple running processes on any Windows system, the process has been a target for malicious use. Adversaries create malware to masquerade as this process and try to hide among the legitimate service hosts. They can name the malware service host or misspell it slightly, such as SCV host. By doing so, the intention is to go under the radar. And another tactic is to install/call a malicious service, which is the DLL. So actually reading, there's a hexacorn block here. Topographical homomorphic abuse of service host.exe. So a lot of times you'll see some of these guys right here where maybe they have some typo squatting type of effects where you're changing the name just enough to where it seems like it's normal and then it's actually not. And then they can run these malicious DLLs, which are in the background, and then execute their malware. So what is normal? Make sure it's verified, the image file path, the process command line, the TAC-K, right? And then when started, and then the parent process being services.exe. If they have a different parent process other than service, image file path other than this, so misspellings or the absence of TAC-K, it is suspicious. So what single letter parameter should always be visible in the command line or binary path? And that is K. LSASS. So this is probably one of the most important, executables on the Windows system. Mainly for an attacker, you're going to want this so that way you get all the credentials as much as possible, right? The other side of it is for you as a user being able to log into your computer. You need this so that way you can actually authenticate. So this is operating the Local Security Authority Subsystem Service is a process for Windows that is responsible for enforcing the security policy on the system. It will verify users logging onto a Windows computer or server, handles the password changes, create access tokens, and it also writes this Windows Security log. So it can create security tokens for the SAM, Security Account Manager, Active Directory, and NetLogon, and it uses authentication packages specified in this file path here. And you can see all the different things that are going on with that. You can even see single sign-on, Kerberos if you're using that for your Active Directory setup. So all kinds of different fun stuff. It's also another process adversaries target. Common tools such as Mimikatz use to dump creds, or adversaries mimic this process to hide in plain sight. They do this by either naming the malware by this process name or simply misspelling the malware slightly. So here we can see some extra reading. So how can you use it, right? So use and additional features Microsoft put in place to prevent these. So here we can see there's LSAS service right there. Let me get down to the nitty gritty. So here we can see we could do pass the hash attacks. So once we get the hashes that are stored in process memory, we can pass that to other systems on the network and effectively compromise those as well without even needing to know what the password is. Then we can also, here they're saying pass a hash or PTT. Pass a ticket, yeah. So this is with your Active Directory. There are things called deodorant tickets, which once you get to the domain controller, you're passing tickets, creating your tickets. You're doing things like Kerber roasting, right? Once you can create a ticket, you effectively have access to every single system on the network, on the domain, because you have a ticket, like a Willy Wonka's golden ticket, to get into everything. And so pass a hash, pass a ticket are very similar in that aspect. So here we can see Windows 10 Credential Guard, and this is with that, again, AISO. So here we have Enterprise, you have LSS with NTLM and Kerberos. Here you're going to have your single sign-on, your creds, right? So for maybe if you're using that for different aspects of your domain. So there's a lot of fun tools. Mimikatz, like they mentioned, is one of the big ones that will try to abuse LSAS. So I currently have something set in place for the training range, actually, where I don't use Mimikatz. I use something called the COM SVCS DLL, which is not mentioned on this. So let me see if I can. So yeah, so this is how that works. So here you can do the run DLL, which will allow you to run the DLL of COM SVCS and mini dump. So mini dump is a feature of the DLL here that will allow you to use. It's mainly used for debugging purposes, right? But you can dump mini dumps from the process, which will effectively allow you to see what's going on. Maybe there's something happening with it. So it's an administrative tool, but with mini dump, I, as an attacker, can, once I have the authority, or if the account has the authority to do this, I can mini dump the LSS process with the full dump and effectively dump all the information from the LSS, so your credential hashes and things of that nature, and go about getting some passive hash action going on, or maybe if I want to start trying to crack it, I can do that as well. So here we can see some of the different things. We got Task Manager, so if you want, let me see if I may not be able to, but I will see if I can demonstrate. So we have, let me go details. So where's LSAS? So here's LSAS. So if I'm an administrator and if I have the permissions, right, I can create a dump file. As you can see, it looks like I can. So here I can go to this file directory right here. So let's copy that. So let's open up a notepad, and you can see here all the different information about the dump from the LSAS. So a lot of stuff what's going on, right? So there's some things you're going to do to kind of figure out what's going on here. Maybe having to maybe format it in a certain way, right? But it is a process of way we can get access to LSAS and kind of dump some of that information. So There's different kind of detections. It's mentioning here. Here they're doing the dumping creds with the mini dump. So here they're executing it, and then they're getting that else has dump. So different kinds of stuff here. It's pretty cool. But yeah, that's effectively a way, even in Windows as an administrator, right? I can dump LSAS and not take it down entirely. I can just get some information from it. So just something neat I found while experimenting and learning on my own. So parent process for LSAS, that's gonna be when. There we go. Make sure I spelled it right. And then when log on. So this is gonna be responsible for all the it says secure essential sequences, right? It is Alt Control Delete key combination user presses, enter the username and password. Responsible for loading the user profile and loads into user.dat into the HKCU or the registry, and the user init.exe loads the user shell. So this is for that if you're on that domain again with a domain controller, they're logging in with their domain credentials and stuff. This is that profile. And again, you can read it here in the Microsoft user init page, different information there. So you can see there's a shell, the user init. It's responsible for locking the screen, runs the user screensaver, among other functions. And again, you can read here on Wikipedia. So from our section, you can see SMSS launches this process along with a copy of CRSS within session 1. Here's that one logon. And then what is normal, right? So it's normal if we have it in the right file location, the process command line directory, maybe the start whenever you actually ran or turn on your computer, and then the parent ID. Again, it's with that SMSS, right? Because once SMSS launches it in session 0, it copies session 1 and then self-terminates. So that's why I shouldn't have a self process up there for parent. And then it's again session 1. So important note. So an actual parent process, image file path other than system there too, so misspellings, not running system, and a shell value in the registry other than explorer.exe. So shell value in the registry other. So shell value right here in the registry for when logon. And then that is smss.exe. And then our last one here is explorer.exe. The last process here again is Windows Explorer. This is kind of the way you can access your folders and your files and basically all your functionality. You're basically kind of like your GUI, right? This is you can get, I guess technically you can terminate Explorer.exe, but it's just gonna be a black screen. So I can try demonstrating that real quick. Whenever we get to there, let me pull it up. I think it's kind of funny. The reason why I'm laughing about this is because when I was doing the training range, I had something that I was trying to clear the screen, and Explorer.exe was one of the things I recommended, and I would basically kill it and then restart it, and it didn't restart, and it kind of caused some issues. So I can demonstrate that too. So here we can see when Explorer, as previously mentioned, when logon process runs user init.exe, so it launches that value here, right? This exits after spawning explorer.exe. Because of this, the parent process is not existent. So user init exits after spawning explorer, not SMSS. And there will be many child process for Explorer. So as you can see here, you got the VM tool here for their VMware, the process hacker, the CMD, everything else that's running on the system. And then what's normal, right? You have the image file path location, you have the command line, the current directory, and then the parent process. Because again, when it init, as it mentions up here, or not, excuse me, not when init, user init, it exits after it spawns explorer.exe. So what is unusual? An actual parent process. So user init calls it and then exits, and then image file path other than C Windows, running as an unused user, so misspellings and outbound TCP/IP connections. The above image is the Explorer exe properties view from the Process Explorer. User init.exe. So make sure there's nothing else. So let me see. So this is Windows now. So yeah, it was fun trying to troubleshoot this because again, I was trying to clear the screen and reopen it back up, and it wasn't doing that. And I'm like, what is going on? What happened to Windows? So just a little funny thing that happened. So, but in conclusion, right, it's important that we understand how Windows operating system functions as a defender. And it's also important that we understand what are the vital processes that Windows uses and how can we identify that unusual activity, right? So with the introduction of Windows 10, there's been new processes been added to the list, and we need to know understand that normal behavior. It's also mentioned earlier that if credential guard was enabled on the endpoint, an additional process will be running, which is that LSAISO exe, and then which will be a child process to when in exe. So be mindful of that as well. It works with LSAS to enhance password protection on the endpoint. Other processes within Windows 10 are the runtime broker exe, task host WEXE, also formerly task host, and task host X exe. So research these processes and other processes you might be curious about to understand. So information from this room is derived from these different sources here. So some good stuff. Pull up Sans. See if it's what I think it is. Yes, I've actually been wanting to find this. I'm glad that it mentioned this. I have been wanting to find this page for a while. So yeah, this is a really powerful page. Um, so as you can see here, there's tons of different courses that recommends for helping you out, maybe hinting. So there's 577. That's the one that I'm gonna be taking here in a bit. So super cool that I got this. 508 is pretty good too. That's one that I would like to take as well. Advanced incident response threat hunting, digital forensics. This is more for your, I think it's Windows mainly, but something else I'm interested in taking. 577 is pretty good. I'm 504. There it is. GCH. That's what I got. Hacker tool techniques, instant handling. So really cool. Really glad to see all this. But here you can see again the basically copy paste for each of these services, right? And going down the list, you can even see how we were hunting for lateral movement with these. So some sources, right? The destinations with the event logs, registry, file systems, remote command execution. So really cool. Actually, I'm gonna download that because if I don't, I will forget. Awesome. I am so happy that's there. I think we've already looked at this, guys, but we'll check it out too. No, there's something else. Okay. So, just kind of go over more of what they just went over through here in the lesson. Just going back through it. And then some Windows internals, I guess, are just explaining each individual piece if you're interested of that. So, and then there's a book about the table of contents about each edition of that. So, and then it looks like there's two parts of it. So if you're interested in the Windows internals, getting kind of a view from Pearson, looks about 50-ish bucks, 60-ish bucks. So it just depends. 120 bucks, So really cool stuff there. Again, I'm super stoked about that. Actually, I'm going to save this page because I know I will forget. So let me just throw that to my quick links. Crucial. Awesome. I am so happy about that. I'm gonna go back through. I didn't do it while we were going through just because I wanted to make sure we get through the content. All of these I'm gonna go back through and copy paste into my notes real quick because I feel like all of that is extremely useful and helpful. So I just figured I'd just go through the course first before I go back through. So, but anyways, we got through two of them today, so not as long of a video, hope, but we still got a couple more. So we got 1, 2, 3, 4, 5, 6, 7 here left. So hopefully we'll be able to knock that out. And then again, seeing we've already knocked this out. Again, you'll see that video once we get to that point. I'll just upload it. And then digital forensics, super excited for this section, not gonna lie. I am extremely excited to go over through all this because this is my job. So I like doing that, fishing, and then the capstone. We haven't done that, so only what 1, 2, 3 sections left. technically there's more, right? But that content's already covered. So, but three sections left, and we'll be done and knocked out. So, super cool. Hope you enjoy this video. Again, I do apologize just for the whole delay of not actively posting. It's just been kind of chaotic with just trying to get everything done and finalized, and trying to get college done and everything. So just got quite a bit on my plate. But I had some time today, so I wanted to make a video. But yeah. So hope you guys enjoyed it. Please let me know what you like, what you don't like, what maybe you think I should be doing different. I really do want to make these videos entertaining and enjoyable. I know in the past I've kind of had them like hours long, and I know that can be kind of rough for people to sit down and dedicate that time to listen and pay attention, right? But I do hope that it can still be of use. Maybe if you just want to skip around, find the different contents that you're actually interested in, or maybe if you just want to use it for study material too, right? Maybe you want to listen to like on a playlist or something. I'm not sure, but I just hope that this stuff and this material is beneficial for you, like it is for me. So, thank you for watching. Hope you enjoy it, and I'll see you guys in the next one.